All right, Integrated 3 students, we're continuing with our lesson over inscribed and central angles and finding arc measures. That's going to be our goal for today, and we're going to go ahead and get started with a problem. So let's go ahead and get into it. All right, so here we have the first problem. Move my camera over. Center top here, I suppose. Okay. The directions say find each angle and arc measures. All right. So it gives you this angle here, 21 degrees. I'm going to pause it and see if you can fill this in. Okay. So I'm going to give you a few moments to try to attempt this problem. All right. So you had some time to attempt this problem, and we need to remember the rules that we had in our last lesson. And for this first one, measure of JK, well, that's the arc. So this symbol here means arc, all right? And this is our central angle, this 21 degrees. And one of our rules that we wrote down, I think it was the last one that we did, is that arc measures are equal to their central angle, their intersected central angle, okay? And that was something that we practiced on Delta Math, which, by the way, my internet is out right now, and it is what, 5:25 a.m. They said it'd be ready to go by 6. So I do not have Delta Math to pull up, so we're just sort of doing this without internet. But this is going to be 21 degrees right there. So inside of here, we're going to put 21 degrees. Let me make that a little bit. Maybe I can make my font size bigger. Okay, 21 degrees goes here. So hopefully you were able to get that. Let's look at the next one. It says measure of angle Jnm. So Jnm, we're actually interested in this angle right here. So how can we find that? Well, if we compare 21, this angle here and this one here, we know that combined they should be 180 degrees because it's making the semicircle. Also, this is what we call supplementary. Right? These are supplementary. I think I spelled that wrong, but you know, that's, sorry, I just apologize. Supplementary is what that should be, okay? So they add up to 180, so we can just grab a simple calculator and just do 180 minus 21, and it's 159. So this is 159 that goes right here. And so we're gonna put that in this space. Okay, 159, so that's in there. All right, 159. Next, we need KL, arc measure. It says arc KL, so K to L. Well, we don't really have the central angle, and we don't really know what that would be. There's a couple ways we could find this. First off, J to L is 180 degrees, so we know that 21 and whatever this arc is should be 180 because the whole circle is 360, so this should be whatever the complement is of that. So we already did that. We did 180 minus 21, so this should be 159. Okay? Which would also imply that this angle here is 159. And maybe some of you are already thinking that when you were looking at this and you did it that way. So there's sort of two ways you could have done it. These have to be congruent here and here because they're called vertical angles. That was a definition that we had on our last set of definitions, vertical angles. So we're going to put in here KL is 159. Okay. All right, so now we get what we call a major arc. Whenever you see 3 letters, that's going to be a major arc. Major arcs always have to be greater than 180. So if you ever get a major arc that is less than 180, you know you did something wrong, okay? So J, K, all the way to M, that's how you follow. It's going to be around the circle, the way the letters are presented, J, K, M, okay? So we're going to combine these. This is 21, 159, and then what does this one have to be? Well, that's also 21 because of vertical angles, which means this is also 21. So some of you are able to do that mental math, you know, just the addition in your head, that's fine. It's going to be 21 plus 159 plus 21. So 201 is what we should have got there. You could have thought of that as 180 plus 21, or however you wanted to do it, you would have gotten this answer, okay? Very good. Next, we need MKL, major arc MKL, that's going to go here. Well, so from M all the way to K, all the way to L. So that's almost the entire circle, except for this one little sector here of 21 degrees. So basically, we could think of it like this. The whole circle, 360 degrees, without this one part. So minus 21, and we get 339. Or you could do 159, 21, 159, adding those up, and you should get 339 here, okay? So hopefully that was not too bad for you. In the next video, we'll practice with some more examples with variables. So you know what? Let's just go ahead and do one of these, just to go ahead and knock it out. Let me find one that's really good. Let's do this one right here, okay? So over on the side, actually, let me pause and edit this so that it looks pretty good. Give me 1 second. All right, here it is. Let me move my camera. All right, so we have the same scenario. We're talking about arc measures here, and now we're throwing a little bit of algebra into it, so algebra fans rejoice. But we need to find all of these arc measures, and it starts with solving for x, and then you have to plug values back in to get their true value, okay? So I'm going to pause this and give you guys some time to see if you can work it out and get it to work, okay, and get your solutions correct, okay? All right, so you had time to work it. Let's talk about the strategy. If you're confused on what actually needed to happen for this, hopefully this will make sense, all right? All of these arc measures, we have two of them we have the actual measure for, and then we have two that are unknown. We have to solve for them. But every single arc measure, when we add them all up, has to equal 360 degrees, right? So when we are trying to solve this, we are going to create an equation. And obviously when you saw x, you're like, oh, well, I should be creating an equation here. And that's going to have to be a part of this. If you didn't think about that, then now you know it now. So let me write up an equation that we're going to be using. I'll write it pretty big here. So we're going to do 360 degrees. We know that has to be equal to this first angle, 9x minus 22, plus the next angle, which is 61. We're just going to go around the circle, plus 5x minus 7. And then we have the last arc measure, excuse me, these are arc measures, which is 34. There we go. There it is. So this is our equation that we need to use to solve this. So all we have to do to start this is we have to simplify the right side. Well, how do we simplify all of this? Well, you just combine the like terms. So and because there's no multiplication happening, I can actually get rid of these parentheses, and I don't have to worry about those. I can just combine like terms and go about my business. So let's go ahead and write the next part, 360, which I want that to be larger, 28, black, okay? So 360 equals, well, I need to add 9x and 5x, which is going to give me 14x. And then I'm going to add negative 22, 61, negative 7, 34. So grab my calculator, negative 22 plus, that should be negative, hold on, 22 negative, okay, plus 61 plus 7 negative plus 34. So we get 88. Oh, I didn't do that right. I missed something. I added an extra 22. I think it should be 66. Let's try it again. Negative 22, just to make sure I've got it. Plus 61. Plus 7. Make that negative. Plus 34. Okay, it's 66. So we go back in here, we edit this. So it's plus 66. Perfect. Okay, Now, this is an equation that you would have solved freshman year. It's just a two-step equation. We're going to subtract 66. Okay, this goes away. We're going to get, this will be 294 equals 14x. We're going to divide by 14. That goes away. X is going to equal whatever 294 divided by 14 is. So 21. So that means that our first answer here is 21. All right, so in order for us to get arc measure G to K here, GK, we're going to have to plug in 9 times 21 minus 22. We need to know what that equals, so let's see. 9 times 21, take away 22, 167, okay? There it is, so 167 goes in that slot there. H to J, so we need this one. So we're gonna do 5 times 21 minus 7. So let's see what that is. 5 times 21, take away 7, so you get 98. So equals 98. Put that in here. And now we know what all the arc measures are. So anything else, we're just either going to be adding or doing whatever we have to do to find it. So it's H, G, all the way to J. So H, G to J. Okay. So this is going to be a major arc. We know it has to be greater than 180 degrees. We start at H, H to G, that's 61. All the way to J, which is 167. This one here, this arc GK, and then KJ, we have to add that as well. So all of them combined should get 262, okay? Or you'll notice that that was everything except this arc here. So we could have done 360 minus that 98. However you want to do it, it all works, okay? Let's do the next one, GKJ. So G to K to J. Well, that's just 167 plus 34. So we're going to do that. 167 plus that 34 degrees, 201. There we go. All right, so that is the answer to these questions here. You actually have delta math problems. You have 2 that are similar to both of the ones we just worked to start off this lesson. And so you should be good to go on those now, okay? All right, now we're going to set up for the next part. And here it is. We have the giant circle challenge. And on Delta Math, if you pull up Delta Math, you will see it's 2 problems, each with 2 parts. One of them says lesson, okay? And that's the one that we're doing right here. So you need to make sure that you complete this one. It's almost like proof that you did the lesson and you're completing this one. And we are going to, I'm going to give you a moment, and I want you to spend a decent amount of time attempting this problem. I'm going to move my camera over just a bit here. I want you to spend a little bit of time attempting this problem. If you work the problem, you can check the first 11 in Delta Math. Like let's say you do the first 11 and you need to check it. You can do that to see if you got it right before you continue the video. And then the same thing with the last 10 problems here. You can do the same thing. You can check your work. We had to split it up into 2 parts, but it won't tell you which ones you missed. We remember that from the proofs. That's just sort of how Delta Math is. I'm okay with it. I know that it's very frustrating for some, but if you have if you want me to check your work, you can just send me a screenshot, and I will tell you which ones are incorrect, and that's fine with me. Okay. But to get things started, I want to pause the video. I want you to spend at least 10 minutes trying to get some of these on your own, okay? Use the rules, every rule that we've written down for this unit so far can come into play. Now there's other ideas at work too. So just see how you can do with these. And if you want to take longer than 10 minutes, that's fine with me. But as soon as you feel like you've exhausted your knowledge of this, press play and continue, and I'll start working through each part, okay? One other thing before I pause. you'll notice on the Delta Math it says it would be a good idea to copy the diagram or print this out. So what you can do if you're on a Windows computer, all you need to do is type snipping, and you have this tool here that will allow you. You probably see me do it on screen. You can copy the whole thing, and then you're able to. You can edit it, or you can copy it, put it in like a Word document, or what have you. I wish there was a faster way to print this. I don't know that there is. Oh, there is. What have I been doing with my whole life? I didn't know I could print from these. So you can print, file, print. If you have a printer, that's something that you can do. It definitely helps to like be able to write on this, okay? It absolutely helps to be able to see what the angles are as you find them. So you could also on your computer, if you have this, I mean, when all Windows computers have it, you could write in the angles like this, okay? So if this was 36, I could write that in and I could keep track of it like that, okay? Or just throw it on a picture editor and you could type in the thing. So for instance, I could put mine, like I'm gonna do this, okay? And I'm able to actually type in the angles that I get. The 30, if it was 37, I could put it there and leave it. So I know that one's 37 if that was in fact the answer. So there's a lot of ways that you can do this digitally to keep track of everything, okay? Anyway, it's time to pause. Good luck. All right, so you had enough time hopefully to make a good effort on this. Whenever you were starting this problem, ideally what you would have done is you would have read this statement at the bottom. It says, given that G is the center of the circle, AD is the diameter, it says the measure of minor arc AB is 78. So ideally you would have written that down or put it on your diagram. It says minor arc FE is 105, so that's 105 right here. And then major or minor arc ED is 27, and then minor arc CD right here is 42. All right, so we've got all those listed. I want to change my text color to, we'll make it black. Okay, so we have all those arcs. That's the given information right there. Now we begin. Okay, now we begin. Obviously, it's natural to start at number 1. So we look at angle 1, that's B. Let me change color here. I'll make this green. B, A, C. So there is not a lot of information. Obviously, we haven't found anything yet. But if we're able to find this arc right here, then we can find this angle. Okay, that should be one of the first things that maybe you tried or thought of, hopefully. If you skipped one, because it would be natural to want to skip number 1, that's fine. You know, you could have found other answers almost immediately, but we can find this if we can get BC. Well, what is BC? Well, we have 78, 42, 27, and 105. The whole circle is 360, but we also don't know what AF is. Okay, so if we added all these up and set it equal to 360, we would have these angle measures. We just wouldn't know what they were. We can't assume that they are the same, so that won't work. But we have something else that we can use. Arc A to D is a semicircle, right? It's the diameter of the circle. It's a semicircle. That was one of our definitions. So we know that 78 plus 42. So from A all the way to D, 78 plus this plus 42 needs to add up to 180. So I can actually find BC by taking 180, subtract 78, and subtract 42, and I get 60. So we know that this arc measure here should be 60, okay? We can do the same thing on the bottom as well, which I'm gonna do. 180, take away 27, take away 105. So we know that this one is 48. So all of that is going to be very useful for us to find these angles. Now, let's go back to angle A. Okay, let's talk about angle A. We wrote down a rule about these types of angles. Look at BAC, angle 1. Is it what kind of angle is that, right? All the points are on the circumference of the circle. All the points are on the circumference of the circle, and that makes it an inscribed angle. So the rule we had for inscribed angles, if you look back in your notes, was that they're going to be half the measure of their intersected central angle, which the central angle would be BGC, which would be congruent to the arc measure BC here, okay? So this angle 1 has to be half of that. So that means this angle here is 30. So 30 is the first answer we get. All right, so we have that. Now, let's look at angle 2. Also, I kind of want to change colors of this. Let's make it blue, just so we know. Okay, blue. And let's do this. All right, so let's talk about number 2. Angle 2 here. Well, let's look at the angle there. It's ABD, which is also an inscribed angle, right? And it's inscribed around this semicircle, okay? Or it's intersecting with the diameter of the circle. So we know that this degree here is 180, right? And we said that so is the semicircle. It's 180 degrees for that arc measure. So it has to be half of that, which means this is going to be 90 right here. That is a right angle. That was actually a rule we saw in the video. Remember, I took the central angle and made it 180 degrees, and then we saw that no matter where it went, it was always 90 degrees. Okay, so that's an important part of that. Let's look at the next one. Let's look at number 3. So with number 3, we see it's CBD. All the points are on the circumference, and that makes it an inscribed angle around this angle 42 right here, okay? So 3 has to be half of that 42. So we're gonna put 21, okay? Has to be 21 here. We're gonna keep listing out all of the parts we have. Okay, let's look at 4. 4 is the angle BCA, which is inscribed. It is inscribed and intersecting the arc AB, which is 78. So it's got to be half of 78. Just to confirm, 78 divided by 2 is 39. So 4 has to be 39. All right, so 39. There we go. All right. What about 5? Well, 5 is BDA, which is actually going, it's inscribed because all points are on the circumference. It's around the arc AB, which is 78 degrees. So it's half of that again. So it's the same as the other angle up here. And if you remember in the video, or in GeoGebra, hopefully you were doing it with me, no matter where we drug that inscribed angle, it always stayed the same as long as the intersecting points on the opposite side stayed in place. It didn't change the angle. It's always going to be the same. So 4 and 5 are congruent because it's almost like moving that vertex around the circle. And if I had internet, which I don't, still out right now, action needed, I don't know, then obviously I would have that up and I would show you. Okay. So we have number 5. So 39. Okay. Now we're on to number 6. Number 6. Oh, we're down here on the bottom. Okay. So number 6 is it is also an inscribed angle. It goes FDA. Here's the arc. It's 48. It's the one we found earlier. So it has to be half of 48, which means 6 is going to be 24. So we're using all these properties here. So 24. Okay. Now what about 7? So let's look at 7. 7 goes from G, F to D. So it's not an inscribed angle, but it's also not a central angle. It's kind of a strange angle to actually try to find. And in all honesty, we don't really have a rule that can help us find this right now. So we're going to pause for a second, and maybe you've already found a way to get it. If you want to pause me and continue trying to work through this on your own, now that we've sort of got the ball rolling, you can do that. But I'm going to skip 7, and I'm going to look at, and I'll come back to it. I'm going to go ahead and look at 8. Okay? Well, let's look at 8 here. 8 is also not an inscribed angle, and it's not a central angle. So I'm not really too sure about those. Okay? So I'm going to pause on that as well. We're going to go to number 9, which we can see is an inscribed angle. It goes from it's FAD, and the arc is the combined measure of these two. So if I add 27 plus 105, we get the arc measure around this. Okay? So combined, 105 plus 27 equals 132. That is the arc measure of F to D, minor arc FD. So we know that this has to be half of that. So what's half of 132? 66. So this has to be 66. And that, by the way, is going to probably play a role in finding the rest of these. Okay? But we'll move on. We'll go to number 10. Number 10 is the inscribed angle CAD, which is intersecting this CD arc, which is 42, so it has to be half of that, so 21. 21 goes right there. Okay, so we got that, 21. Okay, let's look at 11 here. So 11, here is that vertex point for 11. It's kind of all these angles that are grouped near each other. And we can't use the rule that this is not 39, by the way. I've had a lot of students in person that were working this, said, oh, it's got to be 39 because it goes A to B is the arc, right? But it's not an inscribed angle. It's not, all points are not on the circumference, so it doesn't work that way. It's also not a central angle, okay? So we have to come up with another idea here. Well, maybe some of you are thinking what I'm about to say, but you'll notice that this is forming, if we combine these, a triangle, right? It makes a triangle there. And yes, the properties of triangles always apply in any geometric situation. So you always want to be looking for those similar shapes. And now that I point that out, there's triangles all over this thing. There's triangles everywhere. So we can use this rule to help us out in more than just this situation, but it's extremely useful here. All the angles of a triangle have to add up to 180 degrees. So I know if this is 30 and this is 90, how do I get 11? Well, take 180, subtract 90, subtract 30, we get 60. So this angle should be 60. And that's what's going to go in for number 11. I'm going to go ahead and tell you that 7 and 8, we're probably going to be using this rule to help us out, but we'll cross that bridge when we get there. Let's just keep rolling in numeric order. So that is 60. Okay. I'm going to erase this triangle now that we have that. And let's go ahead and talk about 12. How can I get 12? If I know that I have another triangle here, 21, 39, I can find 12, but there's actually a faster way to find it. Kind of like what we did on, well, hold on, it's got to load. On this problem here, this idea of supplementary angles. You have supplementary angles occurring in our problem right here. 12 and 11 are supplementary, so I know that 12 plus 11 has to add up to 180. So what do I add to 60 to get this, to make this relationship 180 degrees? Well, it's going to be 120. And so you could have done that using the triangle method if you wanted to, like we used to find angle 11. But of course, I like to use any rule that I can as long as I know it's true. So what does that mean about 13? What is 13? Well, 13 is opposite to 11 in this intersection. That's what we call vertical angles. We actually used that at the beginning of this lesson too. So it's 60. It has to be congruent to 11. Also, it's got to be supplementary with 12, so it should add up to 180. So that's that one. Okay, cool. What about 14? Well, it has to be congruent to the 12 because they're vertical angles as well. So this is 120. There it is. Yeah, and that's what is kind of so fun about geometry, is that you can just kind of employ any rule that you know is true, and it's going to work. There's so many ways we could find all of these. We could be doing the triangle method for 14. We couldn't have done it for 60, but using supplementary angles, we know that all of this should be good, okay? All right, now we approach the bottom half of the circle. We've got every angle on the top part, okay? Now we're down on the bottom, and hopefully we can get 7 and 8 from our methods here. But we're gonna go to 15 because we're rolling right now. 15. How would I find 15? Well, 15, what type of angle is 15? AGF. You'll notice that the vertex is in the center. It is a central angle. So that's really good because we wrote down the rule that central angles are equal to their intersected arc measures. Okay, so AF is the arc here. It's 48. So by our rule that we wrote down, these have to be congruent. So there we go. This kind of unlocks the door for number 8 now, or angle 8, okay? Angle 8. If I know that this is 66, this is 48, this is making a triangle, triangle AGF. If it's 180 degrees, I could do this. 180, take away 66, take away 48. It has to be 66, okay? Now let's also talk about why we know this is, there's another way we can know that this is true. If I draw the triangle, just look at this green segment here. As far as the circle's concerned, what is that? Well, it's a radius. AG is a radius. Then what about GF? It's also a radius. So we have congruent side lengths, and this is what we call an isosceles triangle, right? A pair of congruent sides. And in isosceles triangles, the base angles are always congruent. So look how 66, and these are both 66. That's because it's an isosceles triangle. So that's just a fun fact. Not super relevant, not super important as far as finding the angles, but as far as understanding geometry, we're seeing it happen here, right? That rule that's always true. All right, so we found 8. I don't know if we can find 7 yet. You might be able to see another way to do it, but nothing immediate. We don't know that these are gonna add to get anything, or at least nothing comes off the top of our heads just yet. Let's just go with the simplest approach. We have 15, by the way, so we're gonna put 48. Let's just move on to 16, okay? And we feel maybe 7 will take care of itself later, okay? 16. 16 is F, G, and now we get E involved for the first time here. FGE. That is a central angle. So the central angle should be congruent to its intersected arc. So FE is the intersected arc. So 105. 16 should be 105. So there we go, 105. Right there. All right, that doesn't really help us with 7 yet, or 21, so we're just gonna keep rolling. Let's do 17. What do we see with 17? G or DGE, that's a central angle, so it needs to be congruent to the intersected arc. So this has to be 27. So 27. There we go. Alrighty. 27, kind of hard to see, but okay. Now 18, how can we find 18? Well, I think we are gonna have to use that triangle property because we see a triangle here that happens for this intersection. So that's gonna be our best move here to get that. So we know that 27, 24 plus 18 should add up to 180. So let's do 180, take away 27, take away 24. So we're getting 129 for this. So that goes there. So 18 has to be 129 based on properties of triangles. Now that helps us find all the rest of these, okay? We know that 18 and 19 have to be supplementary, same way that 11 and 12 were up here. So we know that 129 180 take away 129 should, oh wait, 180 minus 129, so we get 51. That's what this should be, 51, right there. So 51 has to be 19. Okay, 20. Now, since we have these, we know what these others are. The vertical angles here, that makes 21, 29. And then 21 has to be 51. And even though 7 was way earlier in the problem, it's kind of the last one that we're getting. We have 8, by the way, if I skip that, 66 for 8. So now we want 7. Well, we know this is 105, this is 51. So let's do that. 180, take away 105. It makes a triangle, take away 51. So we get 24 here. And we have completed this problem. Okay, we have completed our problem there. Okay. So you may have, I do want to talk about one more thing, and this video's pretty long here, but we've worked the problem. So actually 2 more things. Right here, this angle is also a right angle, just the same that this was a right angle. Maybe some of you noticed that when we were working it, and maybe you used that rule, but it wasn't something that I wanted to state again, really. We did it for 2 because AFD, that angle, is an inscribed angle that is at the diameter, or that 180 degree angle. So that would be 90 degrees. So we could have found 7 after we found 8 because they're complementary. So 90 minus 66 is 24. So we could have done that, and maybe some of you were screaming at the screen, hey, we can do this, and maybe you did it your way. But I just wanted to affirm that strategy there. There's so many strategies in here that maybe I didn't even talk about that worked, okay? And I do want to encourage you to use those strategies to answer your questions. So this was our lesson over these angles. You have a second problem that you'll need to also work, so make sure that you do that. Again, I would encourage you to, if you have a problem, or if you're gonna work it, scan it. You can copy, you can even open up Paint and paste it in Paint, and then use the text tool to start typing in here like this. That might even be another way that you can do this digitally, and you're writing in the answers as you go through it. That might help you out as well, and that is an option that you have. And I think a good way of working these without actually printing anything out or copying it. But I think writing with pencil is helpful. But that's just something that you can think about doing. Just my teacher tip for helping make this easier for you. Okay. So you do have another problem like this that you have to work on your own. The reason I did that is that this problem actually has answer keys online. So all I did was change the angle measures so that the answers would be different. So you'll go through and you'll work that on your own, and everything else that you can do in Delta Math. I do plan on getting another lesson up tomorrow, okay, to talk about the rest of the topics that we have to cover, okay? So I'm going to end the video there.